Hey, good morning, class. So today we're looking at the grade 12 paper 1 in November from the NSC, so that's the department in the year paper. Right, so at this point we got up until question. We do question 8. No, this was our last question we did, okay? Just to recap here, we are told that the tangent to g of x is equal to ax cubed plus 3x squared plus bx plus c has a minimum gradient. So the gradient is first derivative, minimum is second derivative, at the point of -1 and 7. Okay, so the point of inflection, that's actually the point of inflection. That's the second derivative. Okay, for which x will be concave up. They want to know for which values of x will the graph concave up. And we say that g prime of x, we need g double prime of x. So we first derivative, again the derivative, which is the second derivative. At -1, your second derivative is equal to 0. So for A, we realize A is positive, so yes, the graph goes up, then down. So concave up is to the right of -1. That is why we say x has to be greater than -1. My mistake was I drew it at the minimum turning point. It shouldn't have been the case there. People, let's look at question 8. In question 8, we are told that if prime x or if dash x is equal to mx squared plus nx plus k is drawn. The graph is passing through negative a third and 0, q which is 1 and 0, and r which is 0 and 1. The first question says, determine the values of n, m, and k. So what we notice here is that we got a parabola graph here, not a quadratic function. So we follow the formula, y is equal to a into x minus x1 into x minus x2. Where x1 and x2 are x-intercepts. Okay. So we now say y is equal to a into x plus a third and x minus 1. So to calculate a, I substitute the point that's lying on this graph, which is r, 0 and 1. It's an x and a y. So 1 is equal to a into 0 plus a third, 0 minus 1. 0 plus a third is a third, 0 minus 1 is -1, so it's negative a third. A is equal to 1, so a is equal to -3. So my equation now is y is equal to -3 into x plus a third x minus 1. Multiply that negative a third in, and you get negative 3x minus 1 times x minus 1. Let's to get rid of that fraction there. It then gives me negative 3x squared plus 3x minus 2x is going to give you plus, minus x is going to give you plus 2x plus 1. Okay. So my m value is -3, your n is 2, and your k is 1. As the question is to determine the values of a, n, and k. Okay. Let's look at 8.2. 8.2, we are told that, so we just write the equation here. So if prime x is equal to -3 x squared plus 2x. Okay. 8.2 says it is further given that f of x is equal to negative x cubed plus 2x squared plus 2. When I differentiate f of x, I get again f prime x there, as you can see. Determine the coordinates of the turning points of f of x. So we know that The original function is given as this here, so we know the graph is going to turn there, and the graph is going to turn here. Okay, the graph turns on its x-intercepts. So it's going to cut at 2. So that is what this graph looks like. Okay. So here, the x value is going to be negative a third and some y value. And of course here is going to be 1 and some y value. Okay. So how do I get the corresponding y value? I substitute negative a third into f of x. So it's going to be negative a third cubed plus negative a third squared plus negative a third plus 2. So you put in the calculator negative a third is equal, so that's the last answer calculated. So it's negative answer cubed plus negative a third squared plus negative a third plus 2. You 49 over 27. That's not right. We're drawing wrong. Okay, it could be wrong, yeah? There should just be a number under 2. So 2 is a okay, yes, it makes sense. 2 is there. So the graph could be doing this. Coming through here. And of course turning. It's not a good representation of the graph. Let's just draw it again. Okay, of course gonna turn there. Turn here. So that's basically what the graph's gonna look like. Okay. Of course that middle section is not a good representation there. I'm not going to draw the graph again, but something to that effect. So yes, it could be, as long as it's less than the 2. Okay, so this answer is going to be 49 over 27. Let's see how much from 2 is it? Yeah, is that correct? Right. So they want the coordinates, so it's negative a third and 49 over 27. Then f of 1, wherever I see x, I put the 1. So let's just put the 1 equals. That's the last one to calculated, which is now going to give us an answer of 3. Okay, so that's 1 and 3, negative a third and 49 over 27. Okay. Let's look at the next question. That has nothing to do with that one. Question 8.2.2. Check this out. We are told that draw the graph of f. Indicate on your graph the coordinates of the turning points and the intercepts of the axis. So we already know these points here. Okay, and the graph is doing that. It is the cut your y-intercept at 2. We already know that. So the one thing we still need to calculate is our x-intercepts. Not so. So how do you calculate your x-intercept? X-intercept, we let y equal to 0. Okay. The x-intercept, let y equal to 0. So you got 0 is equal to negative x cubed plus x squared plus x plus 2. We divide by negative 1. So you got 0 is equal to x squared, x cubed, minus x squared, minus x minus 2. So now we must test for which value is going to give you 0 on this graph. Okay? Well, definitely 1 is not going to work because 1 is already at 3. Minus 1 to 1. No, negative values will work here. As you can see how this graph looks already. It looks like 2 or 3 is going to work. Can you see it? But say you couldn't make that sense of it. Then you go 1, then minus 1. 2 minus 2. 3 minus 3 and so on. Okay. So what I'm going to do is I'm going to test for 2. If 2 is going to work, So I just press 2 equals, since I already programmed or typed that in already. So yes, 2 gives me 0. Okay. So what does that mean to say? Therefore, x minus 2. If x is equal to 2, people, take it over the equal sign. X minus 2 is a factor. So you got 0 is equal to x minus 2. Now x times what is x cubed? X squared. Negative 2 times what is negative 2? Plus 1. So that means going to give us negative 2x squared. But here we got negative 1x squared. So I must add 1. Not so. I must add an x squared. So x squared divided by x is x. So as you can see, that fraction here, sorry, that the trinomial does not factor out. Not so. So therefore, x is equal to 2 only. So with that is enough information to draw this graph. Remember that my turning points was at 1 and 3, and the other turning point was at the turning points were 1 and 3 and negative, a third and 49 over 27. Okay, which are those points there? Okay, so we got over enough information to draw this graph. So we know that the graph is going to do something like this. Okay, where that is negative a third and 49 over 27. So it goes through 2. There's a maximum value at 1 and 3, and it's going to cut you in. People, it's all by approximation. Okay, that's how we draw the graph. Otherwise, if you wanted to plot the points first and then draw the graph, no problem. You could have done that as well. Okay, are you all okay with that, people? Is there any confusion? No? In 8.3, we are told point E, which is point E and W are two variable points on f prime x and on the same horizontal line. So variable means to say it can move, okay? G is a tangent to f prime x at W. H and G intersect at D. Can we just see this question? Like on the fish. There's a question for you. No. What are you busy with? Okay, so I need the additional function. I think now wait. Let's pull the graph down. It's in relation to this graph. Okay, that's what I was thinking of. Right, now listen. We are told that points E and W are two variable points, which means I can move on f prime x, which is on this parabola graph, and on the same horizontal line. So it will have the same y values. So this is the horizontal line. Say for instance, it is that line. You say you got your y there, y is equal to whatever. So that will be x1 and y, and then x2 and the same y value. Okay. H is a tangent to f prime x at E. So let's make this E, and this is W. H is a tangent to f prime x at E. So if I draw a tangent, that's what the graph looks like, touching at that point only. And this is your h of x. G of x is a tangent at W. G is a tangent to f prime x at W. So that is that one going through there. Okay. H and G intersect at D. So D is this point here, which is A and B. Okay. Write down the value of A. So for people need this, if both are tangents and it's lying on the same horizontal line, okay, the two tangents gradient will be basically opposite, it will be the additive inverse of each other. Which means to say this rise and run at 2, then this rise and run will be at negative 2. Can you see it's the same gradient? If this rise and run here was 5 over 4, okay, then this rise and run would be, that's 5 over 4, then this rise and run would be negative 5 over 4. Can you see that, people? Okay. So which means to say that the A value is actually happening midway between these 2 points at any given point. Which means to say the axis of symmetry is that line going through here. Can you see that? So that axis of symmetry, that distance will be the same as that distance. That distance there will be the same as this distance, but it will still share the same midpoint. Can you see that? So to get the value of A, so 8.3.1, the value for A is simply negative a third plus 1 over 2, which is 2/3. Over, so it's going to be a third, I think. This is going to be negative 1 over 3 plus 1. That's over 2. That gives you a third. Okay. The value for A is a third. Now, determine the value or the values of B for which H and G will no longer be tangents to F. It will only be a tangent to F if those points are not considered any longer. You shouldn't consider E and W any longer. Okay. So if E and W are tangible points or points on the graph, let's first work out B as it stands. Okay. So 8.3.2, as it lies here, we have what is the equation of f of x? F prime x? There is something wrong with this question. Then this doesn't make sense to me. Okay. Then the values of B for which H and G will no longer be tangents. For this not to be tangents any longer, if we take this, exactly this line here, okay, and we move this line up, then it won't be a tangent any longer. Can you see that? Or if I move this down, it won't be a tangent any longer. However, considering what they are saying here, that E and W are variable points, which means to say E and W can move. Not so? But if I move this graph up, E will lie here. Can you see that? Which means to say that this tangent will also go up, which will lie there. and the and the. Can you see that, people? We will move down. Of course, the tangent. This graph will be steeper, but still be a tangent at wherever E lies. Okay. So I don't think this question will be repeated. Well, I just don't understand what they're asking to do from here. Okay. So this is what is the answer in the memo? Let's try and make sense of what they give you in the memo. B is less than 4/3. But this makes sense of what I'm trying to say here is if I consider this line here, okay, and you're saying that B is only less than, which means to say this can only go down, which is not the tangent any longer, which is fine. But what will happen if it goes up? Is this a tangent? No, so it's not a tangent any longer either. Can you see that? Also, if you say, okay, we can't go up because it won't cut the graph any longer, that is fine. But this point E, which is this point you gave us, could actually lie there as well, or there. So this line could go up or down. Not so. So it's either I'm not understanding what they're asking or there's something wrong. Okay. But what you can do is ask your people that helps you with your tuition or whatever. Ask them to explain the question. You bring it back and you can explain to us what they said. Okay. If it is that you're watching the video and you understand, you just email me and then we can see where my misunderstanding is. Okay. Right. Let's go to the next one. There seemed to have been a what's the name paper, no? Nice paper. So I made a couple of mistakes here. No? Alright, people. We are given f of x equal to x squared. Determine the minimum distance between 10 and 2. Find the minimum distance between 10 and 2 and a point on f. People, what type of graph is this? It's a parabola graph, not a quadratic function. So that is what this graph is going to look like. That is your x squared. Not so. What's wrong? So parabola function, not so. So this is y is equal to x squared. So determine the minimum distance from there to a point 10 and 2. Let's say 10 and 2 is approximately. Any point on here, a variable point, they want you to find that minimum distance. So on this graph here, we'll call that x, and what's the corresponding y value for that point? Y, which is x squared. Not so. What is y? Simply x squared. So they want you to find the minimum distance between those 2 points. How do we calculate distance? Distance formula. Not so. The distance is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared, which simply gives us 10 or x minus 10 squared, or 10 minus x squared is the same thing, plus x squared minus 2 whole squared. Okay. I'm going to tidy this up a bit. So your distance is going to simply be x squared minus 20x plus 100 plus x squared, which is now x4, minus 4x squared plus 4. Okay. Which now gives us x4 minus 3x squared. No, not minus 3x squared. Yeah, x4. Yeah, minus 3x squared. Yeah, correct. Yes? Sorry? This here, 4. Because it's that times 2. Let's check if I'm not making a mistake. Yes, it's negative. Yes. Plus, not plus minus 20x. Okay. Plus 4, plus 1 over 4. Is that correct? The multiply out correct. Right. So what happens is now I got a function to the exponent 4. Okay. So this is something to note is that on the side is that the square root of a maximum number. Say, let me say the square root of 4. What's the square root of 4? 2. What's the square root of 8? 2 root 2. Not so, which is greater than 2. Not so? What's the square root of 9? 3. And so on and so on. So which means to say, as this number is larger, getting larger, the corresponding answer is also larger. Which means to say that the maximum value under the root, if I take the square root of that maximum number, will give you a maximum answer. Does it make sense? The square root of a maximum number will give you a maximum answer. So if I take the derivative under here, and I find the maximum, and then take the square root, it will still be a maximum. Does it make sense? Alright. So what we do is, we say, okay, let's take the derivative. Let's take this here. And say that is A is equal to x4 minus 3x squared minus 20x plus 1 over 4. And apply the derivative with respect to x. It's going to give you 4x cubed minus 6x minus 20. Okay, so what type of graph is this? What type of function is this now? What type of function is this? A cubic function. Which means to say, this graph is going to go up then down. Not so? So, the maximum precedes the minimum. Not so? The maximum precedes the minimum. If this had to be minus, then the minimum would have preceded the maximum and I would draw the graph the other way around. Can you see that? So, if that is the maximum, I need to know which x value does the maximum occur at. And how do I get that value out? How do you calculate the turning point? Derivative again. So I'm going to apply again the derivative. So the derivative, the second derivative, it's either that or d squared a over dx squared. I think it's the first one. If I'm not, I was wrong there again. So it's going to give you 12x squared minus 6. Okay. So what I do is I set it equal to 0. Gives you x squared is equal to 6 over 12, which is half. The square root of that is going to give you plus minus 1 over root 2. Why do I get two solutions? Because one is a max and one is a min. So which one of the two is the maximum occurring at? At x is equal to negative half. Can you see that? The minimum will occur at x is equal to half. That's why it was important for me to know which one precedes, which one comes first. So what I do then is I say your area, or A, not area, A, is in, yes?
Isn't it equal to root 2
I took this over the equal sign?
No, it's not the when you say the maximum. You say x is equal to root 2 maximum.
So I took the square root here, introduce plus minus, that's not the issue. No? So the square root of 1 over 2 is, the square root of 1 is 1, the square root of root 2 is root 2. If you want to put in a calculator, you're going to get the root 2 over 2.
I'm saying your final answer is negative half.
Oh, yeah.
Yes.
Thank you. Thank you. Looks like you're taking note. I like it. Okay. So people, what do we do with that? we sub this back into here so that you can get the maximum value. Can you see that? So what we do is we say 4 into negative 1 over root 2 cube minus 6 into negative 1 over root 2 minus 20. So it's negative 1 over root 2. Okay, so what do I do now? I say 4 answer cube minus 6 answer minus 20 gives me, that's not, where did I go wrong? Is this correct? Huh? Right, and then? Delta. So they got this, did they get this out? So that is not the issue, no? And then? Delta here. Of this, and they got this. 4x squared. Let me see. This is 9.2. So you got f prime x. Is 9.1. Okay. Okay, so this is in order. The minus 21 of 4. We find the derivative. We said equal to 0. Yes, that's fine. So you got negative, you got 4x cubed minus 6x squared minus 20. This is correct. And then what they did was they found the roots. So what they did was they said this equal to 0. So why did they let that equal to 0? Oh, I see. My mistake is I'm drawing a graph with a cubic function. That's my mistake. We must consider the graph for a x to the power 4 graph. That's a mistake. So this here is wrong. I'll show you now where it fits here. Okay, so this is x to the power 4. Okay? Which means to say, if we look at the x to the power 4 graph, it looks like that. Or it looks like it. That's x to the power 4. Okay? Which means to say there are a maximum of 3 turning points on this type of graph. Okay? So, the reason why they say that equal to 0 was because that is your first derivative. What's the first derivative tell us about the function? It's a turning point. So the turning point, you see this is positive, so that's what the graph is going to look like. So the first derivative will be there, and there. Okay? Or it could look like this. So, no? Where there's one turning point. Okay, can you see? So since it's positive, it will have a minimum turning point. Can you see that? Positive will have minimum turning point. So what we do is we say, okay, we need to find the x values at which this turning point occurs. So it's set equal to 0 and solve for x. So if you program a calculator to solve a cubic function, that will be 4, negatives will be 0, negative 6, and negative 20. So that gives you x is equal to 2, or x is equal to, as you can see, there's an I, which is imaginary, which means to say it only has one x value at which the minimum occurs. Can you see this graph has a minimum value? If it had to go up, it would have a maximum. So as you can see, it has a minimum value. Okay? So the minimum value occurs at x is equal to 2. So therefore, the minimum distance is going to be the square root of 2 to the 4 minus 3 times 2 squared minus 20 times 2 plus 1 over 4. I would have definitely got the sum wrong even if I was tested on it. Okay, but it's fake going to test you guys on it now. So I've explained that to you how it works. Not so? Fruit 17. Okay, that is testing you way beyond what the syllabus actually requires. No? It's a very good question. You would have done something like this in advanced maths or further studies maths, AP maths. Okay, I didn't expect something to come in here. But like I say, when I was tested, I would have gotten it wrong. Because I don't think of this. Because this is in further studies. But I'm sure some people, any of you can like again, ask this to one of your tutors and then maybe they got the easy explanation. You bring it, then we can discuss again. Okay? Don't say your teacher asked you to do. No. Just say you were working through this and you couldn't make sense of it. Okay? Don't say if you say your teacher said, then say no, don't do this now, man. No? Just say you were struggling and then we see what will come up. Okay? People, let's look at the last one, the probability. We are given A, B, and C are three events. The probability that these events or any combination of them occurring is given in the Venn diagram below. Okay. If it is given that the probability that at least one of the events will occur is 0.893, calculate the value of 1. People, at least one of these events occurring, which means that the sum of all of this here is going to equal 0.893. That's basically what it means. You all okay with that? Alright. So what happens is, for y to occur, y is then equal to 1 minus all of that to occur, which is must not complement. So 0.893, which gives you an answer of 1 minus 0.893, gives us an answer of 0.107. Okay. Okay, we're running out of time here. Then B, it says the probability of all three events occurring is x. Okay. Calculate the value of x, the probability that all three events will occur. So we know that all of this adds up to 0.893, not so. So let's go with that. So we say 0.05 plus 0.15 plus 0.05 plus 0.2 plus 0.1 plus 0.183 plus x is equal to 0.893. So x is equal to 0.893 minus 0.05 minus 0.15 minus 0.05 minus 0.2 minus 0.1 minus 0.183 minus nothing. Okay. Gives you 4 over 5, which is 0.16. Okay. Okay. Look at the next question. Determine the probability. I was going to put 0.16 in there. As we need the space here. 0.16. It says determine the probability that at least two of the events will take place. At least two. So which means to say, three can also take place. Not so. Determine the probability that at least two of the events will take place. So the probability would be that, which is 0.15 plus 0.2 plus 0.16 plus 0.1. 0.16 we already plus 0.1 plus 0.2 plus 0.15. It's going to be 0.61. Is that correct? Right. Are events B and C independent? Or B and C independent? What we know what happens for independent events? For independent. What do we do for independent events? The probability of A times the probability of B. If that is equal to the probability of A intersection B, then they are independent. In this case, it's going to be B and C. So I make a B, C, B, C. Okay. So what's the probability of B? Let's go with that quickly. Let's just change the color. We're trying to prove this formula. I'm just going to keep that there. What is the probability of B? It's going to be that plus that plus that plus that. Not so. So it will simply be 0.1 plus 0.16 16 plus 0.2 plus 0.183. Okay? So the probability of B is 0.643. Is that correct? 0.643. Let's look at the probability of C. So it's going to be that plus that plus that plus that. Okay? So 0.05 plus 0.2 plus 0.16 plus 0.15. So 0.05 plus 0.2 plus 0.16 plus 0.15. 0.56. So the probability of B times the probability of C is equal to 0,643 times 0,56. 0,56 times 0.643 gives us 0,36008. No? Right. Now, let's look at the right hand side, is the left hand side. The right hand side, of course, is the probability of A intersection B. So B intersection C, sir. So this is the intersection here. Not so. So the intersection there is 0.16 plus 0.2. That's 0,36. Are they equal? Is the left hand side equal to the right hand side here? No. No. So since it was not equal. So since the probability of B times the probability of C is not equal to the probability of B intersection C. Therefore, events are not independent. We can say the events are dependent. Okay. For the identity to exist, for events to be independent, it must be equal. Can't be almost equal. It must be equal. No? What did I say? Independent. They rounded it off. So this paper really humbles me now. No? Yeah. I would have said not independent, not the independent. Okay, they say it is independent. Okay, I differ because of the decimal there. Okay. Like if we do something in 3, no? Can it be close? No, it must be exactly we proving a what's its name? An identity. And that to me is an identity. Okay, but maybe they can see it different. Right, people 10.2.1. A 4-digit code is required to open a combination lock. The code must be an even numbered and may not contain 0 or 1. Digits may not be repeated. So if we're looking at digits, if we're excluding 0 and 1, what can it be? It can be 2, 3, 4, 5, 6, 7, 8, 9. How many numbers are there? Digits. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 digits to choose from. Okay. Let's look at 10.2.1. How many 4-digit code combinations are there to open this lock? So it's 1, 2, 3, 4. Digits may not be repeated. So how many options? And it must be even. Not so. So if it's even, then the last digit must be an even number. Not so. So this can be either 2 or a 4, a 6, or an 8. So how many options do we have for code for the last digit? 4 options. Then how many options do I have for digit 1? The first digit. You have 8 digits to choose from. Well, the last one must be even. So how many you got for the first? How many you have 8? 7, yes. It has to be the one less. So I've considered one of the even numbers. And the digits are not being repeated. Let's look at the second one. How many options do you have for but 2? 6, then 5. So therefore it's going to be 7 times 6 times 5. 7 times 6 times 5 times 4 is going to give you 840 possible codes. Okay, you guys understand? Let's look at 10.2.2. Okay, let's just move this over here, so in case we need it behind the calculator. Not here. Alright. Alright. Now we are told calculate the probability. So how do you calculate the probability? Number of favorable outcomes over number of possible outcomes. Not so. Number of favorable outcomes over number of possible outcomes. The question is, calculate the probability that you will open the lock on the first attempt if it's given that the code is greater than 5,000 and the third digit must be a 2. So let's go. So the number of possible outcomes, of course, is 840. Not so. That's the amount of possible outcomes. Now, if we're looking at this 4-digit code, so here would be even up. So firstly, the third one has to be a 2. So I'm omitting the 2 now. So how many options do I have for this bit? 1. I only have one option for that. Not so. Then, how many options do I have here? What options do I have in the last bit? Can be a 4, a 6, or an 8. Can it be a 2? No, because a 2 is used in the third bit already. Okay. It must be greater than 5,000. So what options do I have here? 5, 6, 7, 8, and 9. Not so. But what do I notice here? Hang on, there's an overlap here. And there. Not so. So what I do is now I need to break this up. Okay? So, okay? So if the first number, let's say the last number is 4. Let's say the last number is 4. Right? Oh, wait. Let's go with the odd numbers first. This is my model now I'm working. I'm not going to draw no calculation from it because it's too vast. Okay? So, if the first number, 2, 3, 4, 5, the first number could be a 5, a 7, or a 9. So I take 5, 7, and 9. Okay? If the first number is one of those 3, okay? And of course, this number has to be a 2, so there's one option there. And this last number could be a 4, a 6, or an 8. So how many options do I have on the last bit? 3. Not so. There's 1, 2, 3, 4. I've got one bit too many here. Okay, so there's 3. How many options do I have on the first bit? 3. Not so. Then, how many options do I have here? On bit 2. It's 8 digits. I've considered 8, 7, 6. So this can only be a 5. Okay? So that's the first bit. Then, what if the first number is a 6? If the first number is a 6, and this has to be a 2, so what even numbers am I left with? A 4 and a 8. Can you see that? So if this is 6, how many options do I have here? 1. And here? 2. So it's 8 digits, 8, 7, 6, there must be a 5. Okay. What if the first number is an 8? The first number is an 8. Then, the last numbers can be a 4 or a 6. This has to be a 2. Whoops. Supposed to be. This can only be, I'm writing this up wrong. It can only be a 2 If this can only be a 2, there is one option. It can only be a 2 is one option. Can only be a 2 is one option. Can only be a 2 is one option. Alright. So how many options do I have for the first bit? 1. The last bit? 2. So here I've considered 8 digits, 876. So these 5 options. So the number of favorable outcomes is simply going to be 3 times 5 times 1 times 3 plus 1 times 5 times 1 times 2 because of this. These two codes are the same. Okay? Which can be simplified into 3 squared times 5 plus 5 times 2 squared. So the probability is simply 3 squared times 5 plus 5 times 2 squared over 840. 3 squared times 5 plus 5 times 2 squared. And that's over 840. 13 over 160. That correct? Okay. And there we go. As I said, this paper, humbled me. Now I feel sorry for our losses. Okay. People enjoy the rest of your day. Good morning, class.